get back at this. It's a mess everywhere here. Papers everywhere. Okay, I left off at 6.2 with you guys because I felt that 6.3 I didn't really need to go over. 6.3, if you watch Mr. Todd's video, is simply reviewing what sine and cosine look like as a graph. Okay, so graphing trigonometric functions. Remember the sinusoidal shape, up and down, up and down, up and down. And then the introduction of the tan function, which we're going to look at a little bit, but not too much. So that is filled out for you online. I think it's just as easy for you to read it as it is for me to try to graph it and sort of have you understanding what it is. What I would rather do is kind of implement some of the ideas from 6.3 and embed them through 6.4. So even if you haven't really done a lot of work on 6.3, you can kind of skip ahead to 6.4 because we'll kind of go over it. 6.3 was meant as an investigation, something you would do on your own anyway. Okay, 6.4 is transformations of trig functions. What I will say about this is it is nothing new. Okay, not a single thing in this lesson is different from grade 11 other than we're now going to do it in radians instead of degrees. There will be questions in your textbook which are still in degrees, so you still need to know how to do that. But for the most part, we're going to completely transition into radians. And again, every time you see that pi, it's really 180 degrees. So you can sort of transition back and forth. If you're better at thinking in degrees, you can think a little bit in degrees and convert it back to radians. But I would suggest kind of embracing radians and trying to run with it as much as you can. Okay, to review what's going on, I've kind of made a summary chart for how we're going to do some of these questions. This is a long lesson with a lot of worked out examples. I'm only going to do example 5, 6, and 7 with you. 5, 6, and 7 include a bunch of transformations, and if you can handle 5, 6, and 7, you can handle 1 through 4 on your own. So some things to be aware of. If you came from me in grade 11, all this stuff is 100% review. If you didn't, I'm not sure what your teacher would have said, but most of it should be fairly similar. So the idea is you have two initial functions, either sine x or cosine x. And they are both sinusoidal functions that fluctuate between 1 and -1, and one is just a 90-degree phase shift of the other, but they look almost identical. One is just shifted slightly. Now those functions get transformed when you start either multiplying by values or adding and subtracting values. Okay, so in blue here I've listed all the vertical things. So blue is talking about everything that's vertical. Okay, so that's affecting the y values. And then the purple is listing everything that's horizontal. And that is affecting the x values. Okay, so you'll get used to seeing this over and over again because we're going to go through it quite a bit. So vertical values always happen how I refer to as outside the function. So you're not within sine x here. Would be the purple is considered inside. So outside the function, 3 different things can happen vertically. One, you could see a negative, which would be a vertical reflection. Okay, a vertical reflection means you are flipping over the x-axis. Okay, you're changing your y values. A is going to talk about a vertical stretch or compression. This is all written in your notes for you. If the a value is greater than 1, okay, it doesn't have to be an integer like 2, 3, 4. It can be a fraction, it can be a decimal, it doesn't really matter. But if it's greater than 1, it's considered a stretch. So vertically, it is being pulled this way. Okay, if a is a value between 0 and 1, it's a compression, so squish this way. And this is all dealing with your y values, either multiplying the y values or you're dividing the y values. Now on the end of the function, if there's an addition or subtraction, that's going to move the entire trig function up or down. Everything vertical makes sense. So if it's a positive, it's going to go up. If it's a negative, it's going to go down. The note may use different values here, h and k. I like using c and d, so I'm going to use those ones just so I know a, b, c, d. It doesn't really matter. It's just a variable. Now inside the function, things get a little funnier. The negative inside the function is still a reflection, this time affecting the x values. Okay, so horizontal reflection, you actually reflect over the y-axis. The b value inside is a horizontal stretch and compression. This is where it starts to get opposite. So if your b value is greater than 1, it's actually a horizontal compression by 1 over that number. So say this B value is a 3, it's actually a horizontal compression by 1/3. If it's a 5, horizontal compression by 1/5, like an accordion, squishing it this way, horizontal, affecting the X values. If your B value is between 0 and 1, a fraction, say, a third, a half, 4/5, doesn't really matter, then it's a horizontal stretch. It's pulling it this way. If it's a B value of 1/3, it's a stretch by 3. If it's a B value of 1/2, it's a stretch by 2. If it's a B value of, say, 4/5, it's a stretch by, find the reciprocal, 5/4. Okay, so just be aware that this is opposite thinking to the vertical stretch and compression. Vertical stretch and compression, the larger the number, the more you're stretching. Opposite here, the smaller the number, the more you're stretching. Okay, now a C value is called a phase shift. Phase shift is just taking that whole sinusoidal trig function and shifting it all to the left or all to the right. When you see a negative sign, so what appears to be a negative sign, it's actually moving to the right. When you see a positive sign, it's actually moving to the left. The whys and hows of that were discussed in grade 10 and 11 to no end. Okay, it's the actual general term is X minus what we called H before, or C. So this C is actually positive. The negative was always there. So the C is actually moving it right. The negative was already there. But when you see a negative, you move it right. When you see a positive, you move it left. Just think about that. Okay. The other thing I'm sort of known for going over is key points. If you have a set of points that establish what your graph originally looked like, you're going to base all your transformations off of these two sets of key points. All I have done, these are the same key points I used in grade 11, but all I have done is switch them from degrees to radians. So remember I said, if you just think in your head, pi is 180. If I put 180 in for this pi, 180 divided by 2 is 90. Normally, the key points go 0 degrees, 90 degrees, 180, 270, 360. Remember, one cycle, that's an up and a down, is 360 degrees, or 2 pi, right? 2 times 180 is 360. So 2 pi, 360. So what I've done is I've rewritten these key points, but using radians instead of degrees. This you will have to know, memorize. Well, not memorize because you guys are learning online, but have this written. In fact, I would take a screenshot of this. I'll move my leg. Take a screenshot of this so you can have access to this summary chart for when you do the assignment. Okay, it will make your life easier. Okay, so these key points is how we're going to start every question. And again, I'm going to do the 3 hardest examples with you, so it'll make sense. But sine, remember, starts at 0, 0, and then goes up to 1, back down to 0, down to -1, back up to 0. Okay, so when you're looking at what does the general graph look like for this function, it's up and then down. And this all has to be accomplished by 2 pi. Okay, whereas when you're looking at this one, cosine starts up and finishes up. Okay, so just be aware of how it's different. Now, in terms of how you use all these A, B, C, and D values to help either graph it, or sometimes they give you a graph and you have to go the other way, there are a couple little formulas that will help immensely. Okay, one is finding the amplitude or the A value. You can do that by doing half of the maximum value minus the minimum value. So if, for instance, you have a graph given to you and you have to come up with a formula, this will be very nice. It's also going to help you with graphing, so be aware of that. This one is for sure the most important of all the formulas. Okay, period is 360 divided by your B value. Well, again, we're transitioning out of degrees and into radians, so we're going to say 2 pi divided by B. This is not a 6, it's a B. Okay, so period is 2 pi divided by B. Also, of the same note, is B is 2 pi divided by the period. You may need to know that also. So that's just the reciprocal relationship. Okay, period is 2 pi over B. B is 2 pi over period. Like a triangle question. Okay, so that I would say is the most important. D value. D value is talking about how much it's shifting up or down the whole graph. And this is going to be finding the average of your max and min. So if it's not fluctuating symmetrically and the whole graph has been shifted up or down, if you find the average of the max and the min, that will tell you where sort of your midline is what I call it. So this will be an important relationship also when you're calculating things. And then C represents the phase shift, and this is sort of something we did by inspection in grade 11. And we'll continue to do by inspection in terms of where we want to graph it. Most of these questions are very particular about how much of a cycle they want you to draw or on what domain they want you to draw the cycles. So this is necessary, but is the least of our worries in terms of what we're doing. Now, a couple things when you are graphing. You'll say, well, I have all this information. I know how much is stretching, how much is compressing, how much is phase shifting, how much is going up and down. How do I know what scale to put on my graph? Okay, well, your amplitude will tell you basically what kind of scale you need on the vertical axis, and your D value. Between the two of those, you'll be able to figure that out fairly easily. In terms of the scale on the x-axis, you're going to be taking the period and dividing by 4. So the reason I say that is, if you look at this, we have here 1 point, 2 points, 3 points, 4 points, 5 points that we put on here. Well, this is really 1, 2, 3, 4 sections, like 4 equal sized sections. Okay, that's the first section, second section, third section, fourth section. So if I take whatever the period happens to be, in a normal one, 2 pi, and I divide it by 4, so if I reduce this, this tells me how much to increase my scale by. I start at 0, I add pi over 2. I add pi over 2 again, I add pi over 2 again, I add pi over 2 again, and I get 1 cycle graphed. Okay, so this becomes an important part. And you should know this from grade 11 when you did those tide questions. Remember when it said one tide happens every 12 hours? You took the 12 hours, divided by 4, and knew to put a tick every 3 hours. 3, 6, 9, 12. It makes your life a little bit easier. Okay, one thing to note, if there is a phase shift, the scale has to be adjusted. It just has to be adjusted to make sure that you are able to graph right on a tick marks instead of guessing in between. Okay, and I will talk about that in an example once I get to it, exactly how this adjustment has to happen. Okay, so this is the basics. This is kind of the cheat sheet for how we will go through every one of these types of questions. You should either write this down. This isn't really in the note. It is and it's not. This is just kind of like my idea of all the important things you need to know before you can tackle a transformation question. Okay, if you have notes from grade 11, this should be kind of like in that review note, especially if you had me. I stressed all of these things quite a bit in Trig 2 in grade 11. So just take a look through, familiarize yourself with this, and again, the only adjustment we are making is changing from degrees to radians. Okay, changing from degrees to radians. But everything else is straight grade 11 work. Okay. 3 examples. I'm going to do 5, 6, and 7. So if you look through this note, there's a bunch of information in it. It's a really well thought out note. It's got all the math speak you need. It's got a couple examples with 1 transformation at a time. What happens if I just have an A value, just have a B value? They're all great. I'm not saying they're not good examples, but for me to redo this whole note would take, an hour and a half of me explaining. So Mr. Todd's note is there if you want to go through and look at the original ones. I want to go through the 3 that I think are the most challenging, so you can see them worked out. Okay. Of note, depending on when you're watching this, we should have information by the end of this week as to whether we'll return to school or not in this school year. So we should at least have a clearer plan of where we're going anyway. Okay, the example was like this. One of these black markers doesn't work as well as the other, we'll find out. Example 5. Now I don't need to write everything, but it says, state the amplitude, period, phase shift equation of the axis for the function, state the domain and range, sketch. Okay, basically do everything. For this function, y equals 0.5 cosine x plus pi over 2. Okay, we want to sketch 1 cycle starting at 0. Okay, we want to list everything that they said. So they want you to list what is the amplitude, what is the period, what is the phase shift? An equation of the axis for the equation of the axis. No. Equation of the axis is just your d value, but since we have a, it's fine. We don't have a d value here. So basically we're saying d equals 0. So that's the equation of our axis. By axis it means like what, if the whole thing gets shifted up or down. Remember I said we're going to draw a little horizontal line there talking about an axis. They also want us to list domain, range, and then graph it. Okay, so I'm also going to say I want to know the scale also. So this is all stuff that we can tell just based on this formula here. So basically, and this is not an overly hard question, there are two transformations that are occurring here. Okay, we only have two values that differentiate this from y equals cos x. We have a 0.5 at the front, which happens to be our amplitude. And we have a phase shift of pi over 2. So what this means, remember when you see a positive, it's actually going left, pi over 2 radians. Okay, so the whole graph is being shifted to the left, pi over 2. And in your heads, it's very hard to visualize. What do you mean left pi over 2? Well, again, if you're having trouble thinking, pi is 180 degrees. 180 divided by 2 is 90 degrees. This is just taking a cosine graph, shifting it 90 degrees to the left, and the amplitude used to be 1, has been shrunk to 0.5. Okay, so it's been vertically compressed. Okay, so the idea of answering all these is kind of using the formulas if you have to. Amplitude is always listed out front. So whatever this value is here is your amplitude. Your period is 2 pi divided by your b value. Well, a b value would appear in front of the x. This one doesn't have a b value, it's just a 1. So in our case, the period is just going to remain 2 pi. So one cycle occurs within 2 pi radians. Phase shift is again talking about what exactly it's doing in terms of left and right movement. So again, we will say that the phase shift is left pi by 2. We don't have to write radians every time. We'll assume it's radians if there's no degree symbol. So if you just write it pi by 2, we know you're talking about radians. Again, we already talked about this. The equation of the axis is just going to be whatever your d value is, and we don't have one. Domain is talking about what are the x belongs to real numbers. Obviously, it's continuous forever in both directions. So domain is always that. If they're talking about the domain for one cycle, then that's another story. But the domain in general is going to be x belongs to real numbers. The range, however, is always bound. And because the amplitude has shrunk it from going between 1 and -1 to a half and -1/2, that's what you're going to list. Okay, so your range is between -0.5 and 0.5. Now the scale we learned is you take your period and you divide by 4. That's going to help us come up with how are we going to graph it. So our period in this case was 2 pi. 2 pi divided by 4 is pi by 2. So this is what our tick marks want to increase by, basically. Okay? So if we had to draw kind of the skeleton of what this graph is going to look like, okay, we want to increase by pi over 2. So we put a pi over 2 here. If I add pi by 2 again, pi by 2 plus pi by 2 is 2 pi by 2, which is just pi. And you'll start getting used to what this looks like. So it's 1 pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2, which is 2 pi. Now this graph is being shifted to the left, so we better go into the negatives also by pi by 2. And that should be enough for us to sort of cover what's going on. They want us to graph starting at they want us to start at x equals 0. So we don't need to fully, like you can graph the whole thing and then truncate it based on kind of what the restrictions are. Now, in terms of how you would set this up, some people would say, well, I know where the points are on the original cosine graph. I simply want to move it left, shrink it between, we now know it's going to be between 0.5 and negative 0.5. So you can, this one's fairly easy to graph just based on the knowledge you already have. For other ones that are going to get more difficult, you might want to get in the habit of using the key points. So this was a cosine graph. So if you go back to that last chart I had in terms of what are the original key points, you'll get used to these radian measures in the same way you did with degrees. Okay, so before we would always write 0, 90, 180, 270, 360. Well, now you're going to write 0, pi over 2, pi, 3 pi over 2, 2 pi. Cosine starts at 1 and goes down, right? So basically, if you want to start with the key points, and for people that I didn't teach, I'm not sure if you did this, but the idea here is when you look at the transformations, you have to apply the multiplicative ones first. So this amplitude here of 0.5 was really a vertical compression by 1/2. So what that means is we take our y values and we multiply by 1/2. So this becomes 0.5, 0, negative 0.5, 0, 0.5. That takes care of that transformation. The other thing, and I used to say, write your stretches and compressions first, then your reflections, which we don't have in this case, then your translations, which are the additive things, up, down, left, right. So our translation here is left pi by 2, which means we're taking our x values, and because we're moving it left, we're going to subtract pi by 2. Okay, so when we subtract pi by 2 from 0, we get negative pi by 2. We subtract it here, we get 0, pi by 2, pi, 3 pi by 2. Okay, so now these outside points on our chart are the new ones we want to graph. So the first point was negative pi by 2 and 1. Oh, sorry, negative pi by 2 and 0.5 up here. 0 and 0. Pi by 2 and negative 0.5. Pi and 0. 3 pi over 2 here. So in the question it says only graph from 0. So we have one cycle starting over here and going across. They only want to see the one cycle graph starting at 0. So this isn't a full cycle, but can we interpret what the next point's going to be? Because we already have these increments set up, we know the next point is just coming back down because of the sinusoidal nature of what this looks like. Okay, so this here is kind of what the graph is going to look at like for this function. So this is something you may or may not have to do for every question, list all of these things. But when you're graphing, the main point is figure out your scale. That's super important. So you know what exactly to make your tick marks at. Set up your key points. Do your sort, I called it in grade 11, your SRT. Do it in that order, and you should have no problems graphing. Again, you sort of have to wrap your head around the radians, but once you start using it, it becomes quite a bit easier. Okay, that was example 5. 6 and 7, even more interesting in my opinion. Again, I don't know how you guys feel about trigonometry. This is by far my favorite thing to teach. So if we were in class, I'd be more excited than maybe I appear here on a Monday morning when it friggin' snowed for the 3rd day in a row in May. Okay, so example 6 wants us to graph and now here, this is a big one. Negative 4 sine 2 x minus pi by 2 on the domain of between, I'm going to use the notation that we kind of got used to here, 0 to 2 pi, including 0 to 2 pi. So we want to graph everything we can between 0 and 2 pi for this function here. Okay, so negative 4 sine, okay, good. In terms of what we need to know in order to graph it, I guess the main things that you want to look at is, and I would say this is the pattern we used before. The negative is something, the 4 is something, the 2 is something, the negative pi by 2. We have 4 transformations affecting what would have been a natural sine graph. So we start listing them, and we're going to not list them in left to right order, but in order of what are stretches or compressions, which ones are reflections, which ones are translations. So stretches and compressions start here, this 4. It's out front of the function, which makes it a vertical stretch by 4. Got that one. The 2 in here, that's now inside the function. So sometimes we see these a little bit differently. Sometimes there'll be like another set of brackets. Doesn't really matter. But once it's on the right side of sine, that's inside the function. So a 2 is a value larger than 1. And remember, this is opposite. So this is actually a horizontal compression by 1/2. Okay, that takes care of that one. Are there any reflections? Yes. Out front. So this is considered a vertical reflection. Are there any translations? Yes. A negative is actually going right, pi by 2. Okay, so this is helping us figure things out. Now again, I was said very carefully that one thing that's going to be important to us is our scale. Okay, so our scale can be figured out by doing period divided by 4. So then you have to say, well, what is the period? Well, the period comes directly from this. Period is 2 pi divided by your b value. In this case, is a 2. So 2 pi divided by 2 is just pi. So here, our scale should be pi by 4. Okay. Do I need to know anything else about that? Scale pi by 4. Yes, the one thing I said, there should be an adjustment to your scale if you have a phase shift. So if you have a phase shift, which we do by pi by 2, we just have to see what the common denominator between 2 and 4 is. So because the common denominator between 2 and 4 is 4, we'll keep this as our scale. Okay, this will become more clear in example 7, what I'm talking about. But our scale of pi by 4 means when we're ready to graph this, and because we're only graphing it from 0 to 2 pi, we would like to go up by pi by 4s. Okay, so we are actually making quite a large graph here, because we're going to go pi by 4, and then you add pi by 4 again, gives you pi by 2, 3 pi by 4, pi. So think about it, a quarter pi, a half a pi, 3/4 of a pi, a whole pi. Okay, the fractions make sense. A quarter, a half, 3/4. If you want to think about this as 2/4, that's fine. So as you move up, if you had 4/4, you now have 5/4. 6/4 reduces to 3 pi over 2, 7/4, and 2 pi. So they specifically said we had to graph it on this domain from 0 to 2 pi. Good. Now the other thing we have to be aware of, so this is our x scale, all to do here. This helps us with our x scale. Our y scale is directly related to this amplitude. So the amplitude is 4, which means instead of just fluctuating between 1 and -1, is now fluctuating between 4 and -4. If there was also a translation up or down, that would affect it. So you might move the whole thing up, the whole thing down. That will adjust your y scale. In this case, we don't need to worry. So there's no d value, so we just know it's going to be between +4 and -4. Okay, so we can set up the scale of this graph before we actually step foot in what it's going to look like. Now, in terms of finding the exact points, that's where you want to use the key points. Okay, so you start with the general form. So if you think back to the very first whiteboard I had up here, I specifically discussed the idea of these are key points you're going to need to know. Okay, oops, not pi by 2, start with 0. Okay, so sine starts at 0, 0, and then as you increase by what used to be 90 degrees, now pi by 2. Okay, so you start with those. These are at your disposal. You don't need to memorize them since you're online learning. And now you apply all of these transformations. Vertical shift or vertical stretch by 4 means it's affecting your y values. These are all multiplicative. Multiply by 4. 0, 4, 0, -4, 0. Check. We did that one. Horizontal compression by 1/2 means we're taking our x values and multiplying by 1/2. So this becomes 0. You multiply pi over 2 by 1/2. Then you get pi over 4. Think about that. Pi over 2 by 1/2. Pi by 1 is pi. 2 by 2 is 4. Okay? Pi by 1/2 is pi by 2. 3 pi by 4, and pi. Okay, so that takes care of that. You're multiplying by a half. Vertical reflection means we now have to take the y values and multiply by -1. Done. And right pi by 2 means we take whatever values we had here and now add pi by 2. Okay, we want to add the exact same thing. So we get pi by 2. Well, what happens when we have a quarter pi and we add half a pi? We have 3/4 pi. We have half a pi, we add half a pi, we're now at pi. Oops, I should say 3/4. Add half a pi, 5 pi by 4. Add half a pi. We have 4, 5. What the heck? Did I do this one right? 3 pi by 4. Add half a pi, which is 2 pi by 4. Yes, 5 pi by 4. Now this one, pi plus pi by 2. It's 3 pi by 2. Okay, good. 3 pi by 2. So now we've applied all of these. We're able to graph the function as much as we can, and we'll fill in the rest of it based on the fact that we have to graph between 0 and 2 pi. So we now have the points, pi by 2 and 0. Pi by 2, 0. Good. 3 pi by 4 and -4 down here. Pi and 0 comes back up. 5 pi by 4 and 4. You can see the pattern already developing. So we know it looks like this. Is it easy enough for us to then continue the pattern? Of course. Okay, if this within pi by 2 goes up and down, then it's going to do the exact same thing again. So by pi by 4, it's going to go up, come back down. Same thing here. It's going to go down, come back up. Okay, because you're just extending the pattern. You really graphed one cycle from pi by 2 to 3 pi by 2, but you can extend it on either side of that, and it makes your life quite a bit easier. Okay, so a little bit different than last year, only that last year you would have graphed one cycle and left it at that. You're just extending the pattern. Okay, not overly difficult. You know what all of these things already mean in terms of the transformations. Some adding and subtracting with pi's. Do you have to maybe write on a separate page? Yeah, so do I. It's fine. Sometimes adding and subtracting fractions in your head is a little bit tricky. Okay, but not overall too challenging for us. Okay, the last one, example 7. Same idea. And remember, when you're doing the assignment at any time, you can go back and watch the videos, watch how this develops. I mean, on the assignment, you're for sure going to have to graph something with some decent transformations similar to example 6 or 7, so just be aware. Okay, example 7 throws at us y equals 3 cosine half x plus pi by 2. And this is the first time we've seen a d value, -1, and it wants us to graph on the domain -4 pi to 4 pi. So we're going way on the left, way on the right. You'll see it's not as bad as it looks. Like that looks like a huge domain, but quite a few of the transformations are going to yield that. Okay, one thing to be aware of that we have not talked about yet, but you'll remember from grade 11, if there's ever a value in front of the x, a b value, make sure you factor that out. So I factor the 1/2 out, which means I have to factor it out of pi over 2 as well. Well, how do I common factor a half out of pi over 2? Is I take the pi over 2 and I divide by half and see what's left. Well, division by half is the same as multiplication by 2 over 1. Invert and multiply, right? So really what I'm just getting here is pi. Okay, so this changes to plus pi. And then a -1 here. So make sure you do that or else nothing's going to make sense. Okay, in this question they just want us to graph. So again, we're going to be looking at, in any order you sort of want to do this, 1, 2, 3, 4 transformations. Stick with the order and you won't get it wrong. You have to do the multiplicative ones before you do the addition ones. So do it in the sort order. It makes your life easier. Okay, just see what you have. This one here, vertical stretch by 3. This one here, it's actually a number between 0 and 1. Remember, horizontal is opposite, so this is a horizontal stretch by 2. Reflections, none, just write not available. Translations are either up, down, or left, right. So we have two. We have left pi, and we have down 1. Okay, don't forget about our new sort of step that we've been doing. What is your scale? Scale is your period divided by 4. Okay, but again, we haven't looked at our period yet. How do we find period? 2 pi divided by our b value, which is 1/2. So our period is 4 pi. That means one cycle takes 4 pi. So when we're looking at graphing on a domain from negative 4 pi to 4 pi, we're really only graphing 2 cycles. So not a big deal. 2 up and downs. Okay, so here we're writing our scale should be 4 pi divided by 4, which is simply pi. Okay, now, again, I sort of said, well, what happens when we're looking at the tick marks when you have a phase shift? So our phase shift is pi, our scale is pi. Normally you'd find a common denominator to see what your tick mark should be because they're the same. Our scale of pi is fine. So when we're graphing here,